All right, so 7.2 is about properties of exponential functions. And so this is about there's a lot of graphs, obviously, you can already see that. And they're going to have some transformations. So they might have reflections, they might be shrunk, stretched, shifted. I mean, there's a lot of things, so we're going to just start talking about those. So let's talk about the first problem. How does the graph y equals 3 to the x compared to y equals negative 1/3 times 3 to the x? So if you didn't know, if like with this one you don't know yet, so let's just go ahead and start by graphing it. I'm going to make a table and plot the points. So pick your same points as last time: -2, -1, 0, 1, and 2. Plug it in. 3 to the -2 power would be 1/9. 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the first is 3, and 3 squared would give you 9. Okay, so then let's do the second one. This one, if you want to use a calculator, by all means, go ahead. It's okay. So I'm going to pick the same points. So so remember order of operations, we're going to do our exponent first and then multiply it by -1/3. So 3 to the -2 power gives you 1/9 times -1/3 gives you -1/27. 3 to the -1 power is 1/3 times -1/3 gives you -1/9. Okay, 3 to the 0 power is 1. 1 times -1/3 is -1/3. 3 to the first is 3. 3 times -1/3 give you -1. And last but not least, 3 to the second power would give you 9 times -1/3 would be -3. Okay, so let's graph them. I am going to graph them in different colors. It looks like my biggest y value is 9, so I'm going to count by 3s on my axes. And it looks like I need to go both vertical and, the top part and the bottom part. So I'm going to say this is -2, this is +2, this will be 3, 6, and then 9, -3, -6, -9. Yes, you still need to label your axes. Okay, so I'm going to graph the first one in red, so -2, 1/9. Be pretty much right there. Then I have -1, 1/3, so just a smidge above. 0, 1, 1, 3, and then 2, 9. So that is what that graph looks like, something along those lines. Hey, that's a good looking graph. Okay, so now let's do the other one. What color did I do that one? Blue? Okay, so this one, it's going to start at -2, -1/27, -1, -1/9, 0, -1/3, 1, -1, 2, -3. And if we went one more, it would have been -3, -9. So it looks like this. Oh, I got a little off there at the end. That's okay. All right, so let's talk about it. How does it compare? Well, first of all, it's a reflection, right? It's flipped upside down. Now that's the easy part. The harder part is to tell if it's shrunk or stretched. And it actually is shrunk. So this point right here in red is at 0, 1, right? And this point is at 0, -1/3. And so if you look, don't mind the negative. Obviously the reflection is causing that to be negative, but how do you go from 1 to 1/3? Well, it's a shrink by a factor of 1/3. If you remember your shrink rules and how we've done that with parabolas and all sorts of stuff. So it's a shrink by a factor of 1/3. Okay. Let's do the next one. So now how is this graph compared to the other one? So y equals 2x, we'll do that really fast. So -2, -1, 0, 1, and 2. 2 to the -2 is 1/4. 2 to the -1 is 1/2. To the 0 is 1. To the first is 2. And squared is 4. Okay, just to speed this video up, I'm going to go ahead and tell you the coordinates for the y values on this one. If you wanted to put it in your calculator, it gets kind of confusing. Just make sure you go slow. So the first one is 1/64, 1/32, 1/16, 1/8, 1/4. And now I'll just tell you now, I'm going to add 2 more values, 3 and 4, just because we need to kind of see that. And so at 3, it's 1/2, and at 4, it is at 1. Okay, so graph of them. So negative, oh, I gotta label my axes. So it looks like my biggest number I'm gonna need to go to is 4 on my y-axis, so I'm just gonna count by ones. Okay, so I've got -2 1/4, -1 1/2, 0 1, 1 2, and 2 4. So there's that graph. Really good at drawing the first one. Let's see how the second one goes. Okay, so now I have -2 1/64. So almost on the, pretty much on the axis, really close. -1 1/32, 0 1/16, 1 1/8, 2 1/4, 3 1/2, and 4 is 1. So as you can see, this one is increasing, but it's it doesn't look like it's increasing very fast. Let's do one more. So we've done 4, let's do 5 as well. So 5 would actually give you, when you plug that in, it would give 5 minus 4 would be 1, so 2 to the first power would be 2. So I'll add one more at 5, 2. So that kind of gives you a better idea of what's happening. So here we go. Oh, look at that, beautiful. Okay, so let's talk about the difference. Well, I am looking at this point and this point, this point and this point, and I know it's kind of harder to see the other ones because they're not whole numbers, but they are actually the same. So what do you notice about the graph, right? All of the points are just slid over 4 places. So this is actually a translation, right 4. Okay. All right, here's another one. Let's see, what do you think is going to happen here? You know what? I'm actually not going to graph it. I'm just going to tell you what happens. So whenever you do this one, this is actually a vertical, I can't even spell, vertical translation up 10. So it's just slid up 10, and we're going to get into like what all the translations mean. So here's your kind of, let's talk about it. What happens if it has a 3 out front, not the number that's being raised to the x power, but the number out front? If there's a number greater than 1, that's a stretch. And I'm going to say by a factor of 3. So you look at this number right here. Okay, the next one, you look at the number right there, and that tells you what it is. This would be a shrink, because that number is less than 1, by a factor of 1/2. Very similar to your parabola rules, your absolute value. There was something else we graphed, I can't remember. Okay, and this one, oh, the square root ones. Okay, this one, what's happening here? Well, this negative is what's happening. Oh, let's do it in yellow. So that would be a reflection across y-axis. x-axis. X-axis, it's flipped upside down. This one would be whenever you have x minus something, that's a translation, and that is right 2. So if it's up in the parentheses, it has to be up in the parentheses. It's kind of, you think the opposite, just like on the other ones. If it's minus, that means right. Very similar to the other functions that we've done. This one, if it's plus in the parentheses up to the exponent, so when you type those in the calculator, you're probably going to have to put parentheses around it just to give you a heads up. But this is actually a translation left 4. Okay, this one, if you have a minus 3 on the outside, what do you think happens there? It goes down 3. And if you have a plus on the outside, that's up 7. Okay, so those are all the different types of translations that you're going to see, and sometimes they're going to ask you to identify them or write, like as this next one is, it's a pretty cool problem, what's happening. So I really like these next problems, they're fun to me. So the parent function for each graph is below in the form y equals ax or ab to the x. Write the parent function and then write the function for the translation indicated. So remember our rules from 7.1, the a tells you what the y-intercept is. If there's nothing there, then it's 1. The b tells you the rate it's increasing. Okay, so sometimes that's the harder part, in my opinion, to find. Okay, so the a term is your y-intercept, the b is the rate it's increasing. So let's look at this first problem. And when I'm doing these, I try to pick whole number points. So like I'm going to look at this one, because obviously that's the y-intercept. So I'm going to write y equals 1 times, now let's see how it's increasing. If it goes up 0, 1, and then it goes 2, 4, what is that increasing at? Oh, I'm sorry, that's 2, 3. Sorry, it goes from 1 to 3, and then let's go to the next one to 9. My bad, I can't count. So it goes 1, 3, 9. It's exponentially growing up at what? By 3, right? So it's 3 to the x. Another way, you're like, Mrs. Roeder, I don't really need to write that one. You're right. You can, it's not wrong. But another way to kind of cleaner looking way would be y equals 3 to the x. Okay, now this one, the translation they want you to write the formula for. So how do you write right 2? Well, that's going to be up in the parentheses, right? Up in the exponent. So right 2, you do the opposite, so that would be minus 2, close parentheses. And then if you go down 3, that's a minus 3 on the outside. Okay, there's our first one. All right, this one looks like a decay, right? Because it's going down. So we know that the b term is going to be a fraction less than 1. So let's first start with our y-intercept. It is right there. So y equals 6 times something, right? 6 times something. So that could be, so now that's why the rate that it's decreasing looks like it goes down by 3 there. So it goes from 6 to 3, and then from 3 to, it looks like 1.5. So how do you get from 6 to 3 and then 3 to 1.5? Well, you are cutting it in half each time. Like half of 6 would be 3, half of 3 would be 1.5. So this would be 1/2, right, to the x. So you can have it in, I'm going to put it in parentheses because it's a fraction, and for sure you want to do that. Okay, so now we got to do the translation. How would you do that function right there? Left 3, well, that would be y equals 6 times 1/2 to the parentheses x left. If you're going left, that's plus 3. Fun, right? Okay, this one. Now, what's happening on this? It's different. Well, we know right off the bat it's flipped upside down, so there's got to be a negative in there. And so, well, and actually, this is where it comes from. Your y-intercept is -1, so I'm going to write y equals -1 times, okay? So let's find out what it's increasing by. So it goes from 1 to 2, from 2 to 4, or I should say -1 to -2, -2 to -4. So what's happening? It's doubling each time, right? So it would be times 2 to the x. So you can leave it like that, or how you'll probably see it written is y equals -2 to the x. And the reason that I can write that is order of operations, since there's no parentheses, says that you would do your exponents before you add the negative to it. Okay, so that's either one. If you prefer the first way, that's perfectly fine. Doesn't matter. But just know they are the same thing. Okay, so now like what is that function translated up 4? So it would be y equals -2 to the x. Up 4 would just be on the outside plus 4. Last one of these, and this is the hardest one, of course, right? So let's talk about it. What is your y-intercept? It looks like 1/2 to me. Okay, so then it goes from 1/2 to 4, or sorry, to 2. 1/2 to 2. And then you can't see more than that. It might help if you could see the next one, but I intentionally kind of cut it off. So how do you get from 1/2 to 2? What do you have to do to 1/2 to get it to 2? Times what equals 2? Well, 1/2 times 4 equals 2, right? So it's increasing, it's quadrupling by 4. So this parent function would be y equals, you have your y-intercept, so 1/2 times 4 to the x power. All right, and last one, translation, so right 5, so it's going to be y equals 1/2 times 4 to the x. Right 5 would be -5. Down 2 would be -2 on the outside. All right, now let's do compounded interest. So there's quite a few formulas. You've probably seen this in Algebra 1. If not, that's okay. So this is a formula I definitely expect you to have memorized. Last one we did compounded annually. Now it's compounded continuously. So this means it's continuously compounding, usually on a daily rate. So, and I'm going to actually show you a different button in your calculator you've probably never seen. So just keep an open mind. It's not that hard. Just don't freak out. So your formula is A of t equals capital P times lowercase e to the r times t power. Okay, so E is a number. Okay, we're going to get more into it. It's actually an inverse of the natural log. We're going to get to that later. We're not there yet, so just be open-minded and just accept that I'm going to explain more later on throughout this unit. So E is a number, kind of like pi. Pi is actually a number. It's represented by something. E is 2 point something if you put it in a calculator. It is a number. It's just it's part of this logarithms. It's weird. But so just know it is a number. It is not a variable. Just like pi is not a variable, it is a number, but they use a symbol or a letter in this case to represent it. I don't know why, it is what it is. Okay, sorry. So now P is your principal. Okay, E is a number. R is your rate of increasing or decreasing, it depends. And then this is increasing usually, but and then time, T is time, of course. A of t is the amount after t time. So just some words of wisdom. If you have an account, it'll run the numbers, of course, but usually if you are investing money and it's compounded continuously, like the more times it'll build interest, the more money you're going to make. Most bank accounts do not compound continuously. They compound annually, of course, right? Because it would be beneficial for the customer. One thing that does compound continuously is credit cards. They are daily accruing interest. It's great. Don't grow up. It's a trap. Don't get credit cards either. They're awful. Whatever. I won't get into that. Stay focused. So find the amount in a continuously compounded account for the given conditions. So we're just going to plug all this in your formula. So you're going to have your P is 10,000 times E. It's on your calculator. If you need help, either Google it or ask me in class. E to the R, your rate is 3.1%. So this is going to be 0.031 times 4. And when you're typing this in your calculator, be very careful. I'm almost 100% sure you're going to need parentheses around the exponent. Otherwise, it's going to move that times 4 down, just like it's going to multiply the whole thing times 4, and you don't want that. Okay, so stick that in your calculator. Since we're talking about money, you're going to round to the nearest hundredth. So that actually turns out to be $11,320.16 approximately. And does that make sense? Yeah, if you start with $10,000, that's a realistic amount, right? If you get like 50 million or something crazy, that's not realistic, but this is. Okay, now let's do another one. Principal is $800, annual interest rate is 6.3, time is 9.5 years. Let's do it. So we have 800 times E to the 6.3% is 0.063 times 9.5. Stick that in your calculator, and make sure you're sticking in your calculator because you need to figure out where that E button is. 1,455.51. If you are on Desmos, it's under functions. I can tell you that. All right, so now you're going to be using your calculator. This is just something they want you to do in the homework. It's literally all you do is type this in your calculator. It's getting you used to using the stuff in your calculator. Type in your calculator and round it to 4 decimal places. So E to the 3 would be, third power would be 20.0855. Then on your next one, type in E to the negative 5 power. Round it 4 decimal places, and you get this. E to the E. How weird is this? You can do that. It's legal. It'll be 15.1543. And then the last one, 3/4. You can either type it in as 0.75 or as a fraction. You might need parentheses around that one, so be careful. It gives you 2.1170 approximately. I should put approximate signs on all of those. Okay, so that is it for this lesson. I know it was a lot of fun and you had a blast. Actually, I did. I don't know about you. But anyway, have a great rest of your day. Thanks for watching.